Hi, and welcome to Becoming Multiplanetary. I'm your host, RichLB, and with me I have a few co-hosts and a couple of guests. Next, I'm going to be passing off to Mikko to introduce himself.
Hi, I'm Mikko. I host the Deep Dive Fridays and I pop into the other shows as well. And next up, it's SpaceNut.
Hi guys, I'm AnotherSpaceNut. Thanks for listening today. Next up, Kage, introduce yourself.
Hello everyone, I'm Kage, aka Kage, and I'm actually new to the show. I'm really excited to be here. Thank you all for having me. And next up, I will hand over to Angry Astronaut.
Hello, I'm the Angry Astronaut, probably the most obnoxious creator on YouTube, at least when it comes to space channels, and I'm very glad to be on the program.
And that's everyone here this week. So, first and foremost, Angry, I'd like you to take a couple of minutes here and introduce yourself to our listeners. Just let them know who you are, what you do, and where they can find you.
I'm the Angry Astronaut, probably the most obnoxious creator on YouTube, at least when it comes to space channels. I tend to not just report on space issues, but editorialize them as well. And you can find me on YouTube under the Angry Astronaut, obviously. And you're going to find some pretty extreme opinions when it comes to various space-related companies. There are some that I tend to target, and others that I tend to favor, and I don't mince words when it comes to my opinions. That sets me apart, I think, from a lot of other creators on YouTube. I don't think it makes my channel any better as a result, just different, which is what I was trying to do from the beginning. And I've been very fortunate to grow very rapidly. My channel's only been in existence for about 10 and a half months or so, and I'm up to nearly 30,000 subscribers, so I've been very blessed in that regard. So I'm very, very pleased to be here.
That's great, Angry. Thanks for that introduction. That was really insightful. And before I set this week's topic, I'd like to open the questions out to the people we've got on the floor with us right now. Guys, do you have any questions you'd like to ask Angry before we get started?
No real question from me. I just want to first say thank you very much, Angry Astronaut, for joining us. I'm personally a very big fan of your channel. I actually really appreciate your no-holds-barred commentary and opinions that you share. I think that is indeed something that really sets you apart, and it's something that's made me really quite enjoy your content, so thank you for that.
Yeah, I could say pretty much the same. I have watched most of your content and find it really good. For example, your Sunday live streams I usually listen in my car as a podcast format.
So I actually do have one question now that it comes to mind, and maybe this would be something useful for our listeners. What got you into this? How did you get into making, first of all, having the ambition to make a YouTube channel, and what got you into space news and to all of this sort of new technology and new world that we have in front of us?
That's a question that goes way back to when I was a kid. My uncle worked for NASA for most of his professional career. I had the opportunity to watch the Space Shuttle Challenger take off on its maiden flight. So that was really an amazing experience, and my uncle really filled me with a great sense of wonder when it came to space. And then as I started watching YouTube, I discovered more and more of these channels, and I'll name names. Tim Dodd obviously is somebody that, I noticed right off the bat. And then To the Future, What About It? So many of these. John Michael Gaudier being one of my personal favorites. So many of these channels, were reporting on very interesting topics. And so I decided, I really want to do this as well, but, what can I do to differentiate myself? And what I noticed is that, nobody was really, taking these issues on in, in sort of a way that a lot of political commentators tend to. I hate to compare myself with Rush Limbaugh, but in some ways I'm the Rush Limbaugh of the YouTube space channels.
So this week's topic is going to be about future technology to getting us to Mars. So right now we know we've got some technology that already exists that we're using over to Mars, but I'd like this episode to be more dedicated to casting our minds to the future and thinking what kind of technology could we see potentially in shaving time off getting to Mars and getting there more comfortably, more sustainably. And I'd just like to open that to the floor. So anybody, any thoughts on that?
Well, I've done several episodes on nuclear thermal propulsion. There's a great deal of debate about that particular issue right now as to just how feasible it is and how, close on the horizon it is. Had we continued with our experimentation and our development of this kind of propulsion when we began doing this in the 60s and 70s, we would be using nuclear thermal rockets today and already be on Mars, in my opinion. But like so many idiotic things that have happened in the history of the space program, both in the United States and elsewhere, we didn't. And the Russians were pursuing nuclear thermal propulsion as well, and they discontinued their program at about the same time as the United States did. It was always a US versus the Soviets kind of thing, rather than a let's explore the solar system for the sake of humanity thing. That's always been the case until hopefully recently, since people like Elon Musk have made this more about exploring and colonizing the solar system for the good of humanity.
Yeah, and I think the way they work and the way they achieve this is there's a little bit of math behind it, but effectively there's a thing in rocket physics known as specific impulse. And what this means effectively to the layman is how much bang you get for your buck, right? So with chemical rockets, the specific impulse is 2/3 that roughly of what you can achieve with nuclear thermal propulsion. And that's because the hydrogen is superheated as opposed to combusted, and that's achieved through effectively piping that hydrogen gas through the internal workings of the reactor, which in turn superheats the hydrogen, and then you expel it out of the nozzle, and that grants you about 1/3 extra specific impulse over chemical rockets, which is what I found in my research. Anybody else with anything on that?
Yes, I believe that estimate comes from the U.S. Department of Energy. I'm not sure if exactly where you got that, but that is one estimate that's been provided. I think that's overly conservative, in my opinion, based on a lot of other sources that I've gone to. Nuclear thermal has the potential of driving a vessel as fast as almost 10 kilometers per second, according to some of the information that I've seen. Of course, and that's in a perfect world. But still, immense speeds are possible with this design. Certainly not as good as fusion or some other types of propulsion, that are a little further on the horizon. But, we've been using chemical rocket propulsion now, well, for over 1,000 years since the Chinese started launching rockets at their enemies on the battlefield. And, it's time for a different type of propulsion. And there's, some arguments that we're still a long ways away from it. And, I find that to be naysaying in my personal opinion. I mean, if we could have, created the atom bomb and the Manhattan Project from conception in 1941 until, destroying Hiroshima in 1945, then why the hell can't we create a nuclear propulsion in a similar amount of time?
Yeah, and I mean, at the end of the day, this technology, as you said, it was abandoned a while ago now. And, those estimates, I believe, are probably taken from the technology state as it was at that time when it was abandoned. If you think about it, if it was never abandoned and it was allowed to be researched, we could have theoretically improved that efficiency many times over by now. So at the end of the day, the technology can only get more efficient as you research it further, right?
Yes, absolutely. It's one of the things that pisses me off, to be frank. There are so many breakthrough types of propulsion and technologies that have been abandoned on and off over the years. I mean, just 10 years ago, we had come up with an idea of going to Mars using nuclear thermal propulsion, and that also was abandoned. Over and over again, we've had ambitions to, graduate to a more advanced form of propulsion that's, suitable for the 21st century. And we keep abandoning it because, some idiot decides that it's, and I tend to be pretty blunt, as everybody knows in my opinions on this matter, but it just is. It's idiocy. Why abandon something like this when we spend hundreds of billions of dollars, on researching ways to kill? Whereas we could do so much more if we researched more efficient ways to explore and colonize the solar system.
That's actually a really good point that you bring up, Angry, and I think it's worth noting that, especially when we look in more of a future-looking perspective. So back about, what would it be, about 45 years ago or so, 50 years ago, you had the Nerva engines and other sort of research that went on with all of that. And then there was, of course, as you mentioned, that kind of a pause in the research that went into nuclear thermal propulsion. But now, especially, there is I think it's a $158 million budget that is available for that DARPA has allocated for its 2021 budget for space programs. So it does look like that is kind of coming back into a new light, that they're picking up from where they left off. Maybe would you like to go into that a little bit?
All right, so you mentioned $158 million. Certainly there's reason to be optimistic, that we're getting back on track with nuclear thermal propulsion. It certainly seems to be where NASA is moving. It seems that they have an ambition to use that type of propulsion to get, the human species to Mars. But, $158 million is not nearly enough in order to make a practical form of nuclear thermal propulsion to get back to the point that we were at in the 1970s is going to require billions of dollars, not hundreds of millions. But it's something that's definitely worth it. I mean, it's a tiny percentage of the U.S. budget. And assuming that we had no help whatsoever from the European Space Agency, which I think we would have help from the European Space Agency if we asked for it, we could definitely develop a practical nuclear thermal drive within the next 10 years if we put our minds to it. But, we would have to be committed, and I don't see that commitment yet.
Yeah, I have to agree with you. Kind of seems like no one has really wanted to go to Mars or even further. They've just put off developing the nuclear engines, and if you just think about the budgets of military, it would be tiny compared to that. Yeah, I was quite interested to see Starlink terms of service having Mars clause that they won't be using any regulatory advices from Earth.
So, did anybody else get a glimpse of this? How about yourself, Angry, or Rich, Kage?
And to specify, in terms of regulatory agreements or in terms of militarization of the Starship?
A little bit of both, really. Do you think that the military is going to go full industrial complex on Mars, or do you think we will see, as the Starlink terms and conditions dictated, that Mars is independent? How do you feel that should play out? What kind of military intervention should we see for Mars, if any, and where does the boundary lie?
Well, I believe that the moon has an enormous amount of strategic value for military purposes. But as far as Mars is concerned, it's entirely too distant. Now, it depends on the ambitions of other nations when it comes to colonization. I don't, until we see clear evidence, in my opinion, that somebody like the People's Republic of China, I tend to rant about them, quite a bit. But until we see clear evidence that they intend to do something aggressive on Mars, I don't think that any sort of militarization or any sort of military activity is necessary that far out. I think that sets a bad precedent, in my opinion. And there may have been some noise in the background. Sorry about that. But as far as regulatory agreements are concerned, yes, I think that we should have something very much like what we've agreed to with Artemis. I think that no nation should lay claim to any territory on Mars, and that if a colony does start to exist with a large population, then they should be free to govern themselves once they become self-sustaining.
Kage, I know this is your kind of thing. Have you got any thoughts?
So that's a really interesting point, and really when we look at how much a role the military plays in this, we can look, for example, at the space shuttle. The military played a rather huge role in at least initially inspiring a lot of the designs for the space shuttle and some of the initial funding for it. The military even played a pretty substantial role in some ways in the start of the space industry. With a whole race against the Soviet Union, it wasn't just about the nationalism that came with, but also the feeling of national security importance that came with that. So it could be argued that having some of that military power behind a push to Mars could in some ways help it. But then again, it really begs the question, is that something that you really want to have happen? Do you want to have the military be involved in something that should be for the betterment of mankind in terms of science and space exploration? Whereas if you turn it more into a military approach, then it might become more of a territorial aspect of it. And maybe that's not exactly where we want to take our future progress with this. The money behind it could help, but the motives behind it could be questionable.
If I may cut in, one thing I think that Elon's going to very much like the money he gets out of all these military contracts. However, I don't think he's going to like it when they start calling the shots. I mean, it was that very thing that caused the destruction of the Challenger, because there was so much pressure being placed on the Challenger to deliver military satellites into orbit on a regular and swift basis, that led to an unsafe launch when, they knew damn well that those O-rings couldn't stand up under those temperatures on that particular morning. I don't think Elon's going to like it very much when the military start calling any shots on him. And that's where I think the involvement kind of needs to end, is any sort of authority, and dictating terms. If Elon wants to set up a colony on Mars, and the people who go to set up that colony, they should be the ones dictating the terms to the military and not the other way around.
So, cycling back a second here to future technology, we've discussed nuclear thermal propulsion. You also mentioned a little bit back there, Angry, about fusion as well. Now, with fusion, it is certainly a future technology, very much in its infancy right now. The latest on that industry actually is our country, the UK, recently turned on a brand new fusion reactor called the Mast Upgrade. Anybody with any more to add to fusion?
Well, that's a fantastic accomplishment. And yeah, I did read about that actually. And if that plays through to its conclusion and we actually do get practical fusion out of that, then that's going to change everything. One form of fusion propulsion that I did a video on was actually something called the Discovery 2, a design commissioned by NASA that was peer-reviewed using fusion power, and it was based on the ship from the Arthur C. Clarke novel 2010. And the idea behind it was just to essentially create a super nuclear thermal rocket, to use fusion power rather than fission to superheat hydrogen and drive it out at tremendous speeds, allowing us to reach Jupiter in a few months. And we're talking 3 to 4 months rather than Mars in 3 to 4 months. So yeah, if fusion becomes practical, and that's just one of many different ways that fusion could be used for propulsion, plasma being another one, plasma drive being another form, ionizing and driving a formerly inert form of propellant out the nozzle at an extremely high rate of speed, and we're talking percentages of the speed of light. Again, you would need probably the kind of energy that a fusion reactor could generate in order to do that. Once again, we're talking about ships that can explore the outer solar system in a few months now instead of just Mars.
And what about the long-term effects? What about the short-term effects? Because everybody talks about radiation. Has anybody got any numbers on how much radiation, nuclear thermal propulsion system might put on somebody? And does it outweigh what a 9-month travel would put into the human body?
Well, we are going to need protection from radiation and cosmic rays anyway for the crew compartment of any ship. There's a tremendous amount of radiation out there in interplanetary space anyway. So radiation protection is going to come at a premium regardless, and I think that any form of propulsion that minimizes the amount of time that somebody is exposed to that radiation is certainly worth it. And of course, you have submariners who have nuclear reactors on their submarines, and they serve on those for many months at a time without any serious radiation problems. So I think shielding is something that is a problem that we can overcome.
There's actually a YouTube series that I watched, or not YouTube, I'm sorry, a Netflix series that I watched recently called, I think it's called Away, and it has some interesting insights into how humans could potentially travel to Mars. It cuts a lot of scientific corners, for sure, but it also covers some interesting things. Like, for example, they do mention that the ship itself has a hull that is filled with about 1 meter of water to insulate it and protect it from cosmic radiation. And one of the things that they also included in there is a crew cabin or crew quarters area that has artificial gravity that's spinning. But there is actually where kind of the realism of it, the actual physics of it kind of ends, because the artificial gravity is rather close to the center of the ship, which would, in actuality, would actually make them really sick. They would get very sick with motion sickness. But there is something to be said about that sort of technology to protect us and give humans the ability to survive in that long of a time of traveling from Earth to Mars. Angry, maybe you could go into a little bit about some of the challenges that we might face there and ways that we could overcome them.
Well, one thing, the Bigelow modules that unfortunately Bigelow's out of business now, but Sierra Nevada is continuing to push forward with it, are multi-layered inflatable habitats, as most people know about Bigelow. That's the whole idea behind it. But the various layers involved in that actually provide a substantial amount of protection from radiation and cosmic rays. The Bigelow module on the ISS has been subjected to quite a number of tests for the years that it's been up there. and is proven to be pretty effective. I think that there's a lot of different ways as long as you minimize the amount of time that somebody is exposed to radiation and cosmic rays, and also that you have a good shelter, a good solar storm shelter in place for the occasions when those crop up. The long-term consequences of a journey, of a 6-month journey, would probably not be that extreme, assuming, of course, that it's not actually a 12-month journey. If we're talking just going one way and then settling. If you're going both ways, then yeah, the problem becomes worse. That's one reason why getting there faster makes a difference. And that applies to gravity as well. If you can make the trip in 100 days instead of 6 months, then the impact of microgravity on the human body doesn't become as extreme. And one example that I'd like to point out is Christina Koch, when she came back from the ISS. Yes, she was carried out of the Soyuz capsule by the Russians, but within 24 hours, she was on her feet and doing just fine. And that's in a full G, and that's after being in space for a year. So as long as the person is healthy, and also keep in mind Mars is 1/3 G, not a full G. So if you land on Mars and then have a chance to actually just simply stay in the vehicle and get some time to get adjusted to the gravity, I think that microgravity can be overcome, especially when we're only talking about 1/3 G. I don't think that artificial gravity is an absolute necessity for traveling to Mars. It makes things a lot better, but I don't think it's an absolute necessity.
Yeah, I would have to agree. It wouldn't be necessary for the first trips to Mars, but maybe on the way. Circling back to radiation protection, the most interesting news that I read this year, there was a fungi found from Chernobyl that was living off the radiation, and they actually tested that on the ISS this year. The results were something like, with the combination of fungi and melatonin, they could have a 20 centimeter or under a foot thick layer of protection that would cut most of the radiation. Anyone heard about that?
Yeah, I remember seeing about that. It's a strain of fungi that's the only exception of it growing anywhere is at Chernobyl, like Mikko was just saying, and it actually feeds on radiation. They're saying it, in essence, it just it absorbs it to grow, and so it actually thrives off the radiation, and so it absorbs as much of that as it can to be able to thrive. And so as a result, like Mikko was just saying correctly, if you put about a foot of this fungi on top of, say, a 3D printed dwelling, it would be sufficient radiation protection, because it would continue to grow with the more radiation it consumes. So eventually you could actually have like a fungi city on Mars almost.
And there is something to be said about the dangerous nature of this, of astronauts being guinea pigs, that when you look back in the 1950s and 1960s, they were test pilots that were doing these sort of things. They had sometimes even a 50-50 chance that they might not survive a particular space flight. And with the space shuttle, I think that it had something like I don't remember the exact figure, correct me here, I think it was like a 1 in 72 chance actual of not surviving. And with SpaceX, with the Dragon capsule, I think that has like a 1 in 279 ratio, something around there. So there is kind of an inherent risk that's known for this sort of thing, and it's not going to be something that we can make absolutely perfect and completely and 100% safe. So that might be something that, when it comes to expanding the horizons of humanity and bringing ourselves multiplanetary, that there are some risks that go into that, and maybe those are risks that are worth taking. There are certainly risks that those astronauts know when they sign up for this, and maybe it's worth it. What do you think?
Kage, those are risks that are absolutely worth taking, in my opinion. I have no mixed feelings about it. If I did not have children and responsibilities here, I would be perfectly willing to take those risks myself in exchange for the possibility of seeing the Valles Marineris or Olympus Mons in the flesh for the first time. I can't imagine how that would feel to see the wonders of the solar system that are waiting for us on Mars. And, the only downside you can give me is a small possibility of death. I'll roll those dice, and so will a lot of other people. Astronauts are willing to take those risks on a regular basis, and exploring new frontiers always has risks. And I think if you asked any astronaut at NASA or any place else, all of them would answer the same way that I'm answering right now.
Thanks for listening, guys. That's been this week's episode of Becoming Multiplanetary. I've been RichLB, your host for this evening, and I'm going to pass off to my co-hosts.
Thanks for listening today, guys. Bit of a different one for you. Hope you enjoyed Becoming Multiplanetary. Feel free to reach out on Twitter with any questions. We can also take questions directly via the anchor link that's under every podcast.
Ladies and gentlemen, I am Kage, aka Kage. Thank you again for joining us for Being Multiplanetary. Hope to have you join us next time, and I will also be joining you next time if the fine gentleman here will have me again. So it's been my pleasure to speak with you and to again speak with Angry Astronaut, and we'll see you all next time.
I've been Mikko. Thanks for listening, and finally, Angry Astronaut.
Thank you very much for listening. I'm looking forward very much to the next episode and our opportunity to talk more about man's exploration and colonization of the solar system.
Don't forget, guys, to join us next time for part 2 of Reaching Mars, where we'll be having new guests. I'm not going to say who they are right now, but if you keep an eye on our Twitter, we'll be revealing them throughout the week.